y prime if y equals 5 secant to the fourth x. All right, since we have this power here, I'm going to rewrite this problem as 5 times the quantity secant x to the fourth, and this now becomes a chain rule problem. Our u is going to be the secant x. So we're going to have y equals 5u to the fourth. So taking the derivative of that, we'll get 20u to the third times the derivative of that u. The derivative of secant x is secant x tangent x. All right, now we just need to rewrite what we have here. We're going to have 20u to the third would be secant to the third x times secant x tangent x. And now we can put the secants together, so I will have 20 secant to the fourth x tangent x, and that would be my answer. Okay, 23, find y prime if y equals the cube root of x squared plus 4. And once again, we are going to rewrite this so I can use the chain rule. This would be x squared plus 4 to the 1/3, and then this part will be our u, so I'm going to rewrite that as this is u to the 1/3. So y prime will equal, the derivative of u to the 1/3 will be 1/3 u to the negative 2/3, because I'm subtracting 1 from it, times the derivative of my u, which would be 2x. And so then just cleaning this up a little bit, 2x is just going to stay on the top. The 3 is going to move down, is on the bottom, it's going to stay on the bottom, and then the u to the negative 2/3 will move to the bottom and become positive. And now all I need to do is just put my u back in. So we have 2x3 x squared plus 4 to the 2/3 power, and that would be my derivative. Okay, 24. Find dy dx if 2x squared y plus 2y squared equals 4x. I do notice that I have x's and y's, so it's time for some implicit differentiation. I do also notice that I have a product, so we get to use the product rule on this first part, so we're going to have an f and a g. So f prime will equal, the derivative of 2x squared is 4x, and g prime, the derivative of y would just be 1 dy dx. Okay, so using the product rule, f prime times g, 4xy plus f times g prime, 2x squared dy dx. Okay, then plus the derivative of 2y squared will be 4y dy dx again, equals the derivative of 4x is 4. Okay, everything with the dy dx stays on the left side. Everything else gets moved to the right. So we're going to have 2x squared dy dx plus 4y dy dx equals 4 minus 4xy. The next thing we want to do on the left is factor out a dy dx. So we'll get 2x squared plus 4y is equal to 4 minus 4xy. And then the last thing to do is divide. So we'll have dy dx equals 4 minus 4xy over 2x squared plus 4y. And if you wanted to factor out a 2 from everything, you certainly could, but I am just very pleased with that answer already. Okay, number 25, find where the function has a vertical and or horizontal tangent line. So the difference in this problem than problems that we've done so far in this review is we are now dealing with tangent lines, and tangent lines have to do with derivatives. So we would like to take the derivative of this and find out where that derivative would be vertical or horizontal. So the first thing that I notice is we do have a quotient rule, so quotient rule, here we come. So f and g, f prime would be 2x, g prime is 1. Okay, so finding the derivative, we'll have f prime times g, 2x times x minus 3 minus f g prime all over g squared, which will give us 2x squared minus 6x minus x squared all over x minus 3 squared. And continuing to reduce that, I'll have x squared minus 6x over x minus 3 squared. Okay, so that's my derivative. All right, if I'm looking for a vertical tangent line, vertical lines have undefined slopes. So where would this derivative be undefined? It would be undefined when the denominator equals 0. So I'm going to take x minus 3 squared and set it equal to 0. We could, if we wanted to, square root both sides. And if I do that, I'll get x minus 3 equals 0, so x equals 3. So at x equals 3, there is a vertical tangent line. Okay, to deal with horizontal tangent lines, horizontal lines have a slope of 0. So when would this derivative equal 0? It would be when the denominator equals 0. I'm going to factor out an x. So this function would have a horizontal tangent line when x equals 0 and when x equals 6. Okay, number 26, find the derivative of y equals the natural log of the square root of 4x plus 1 divided by x cubed plus 5 cubed. You may decide to do this a really, really hard way using the chain rule and the quotient rule. However, I am going to separate everything first. If I have division, I can separate with subtraction. So this is going to be the natural log of 4x plus 1 minus the natural log of x cubed plus 5 cubed. And I'm going to decide to go further even because if I have a power, I can move it out front. Okay, the square root of 4x plus 1 is like a 1/2 power, so I'm going to move that to the front. So it's going to be 1/2 ln 4x plus 1 minus, I'm going to bump the 3 out front because it's also power, 3 ln x cubed plus 5. Okay, I am now set up to find the derivative. Remember, if we have y equals ln u, y prime will just be du over u. So in this case, this is u, and then this one is u. Okay, so taking the derivative, the 1/2 is just going to tag along. The derivative of this would be du over u, so du would be 4 over u, and then minus, this 3 is just going to tag along. The derivative of this one would be du over u, so it's going to be 3x squared over x cubed plus 5. And now I'm just going to clean it up a little bit. These 2 and the 4 would cancel, so I'm going to get 2 over 4x plus 1 minus, I put a 1 underneath that 3. There's nothing I can cancel this time, but 3 times 3 is 9. So 9x squared over x cubed plus 5. If you'd like to get a common denominator, go right ahead. I'm happy with my answer how it is right now. Okay, 27, find f prime of x if f of x is equal to 3 arc sine of 2x minus 1. Okay, if we have an arc sine, I'm just going to write our formula up here. Y prime will equal du over the square root of 1 minus u squared. So that's the formula we're going to use. This will be my u. Okay, so f prime of x will equal the 3 as a constant. It's just going to tag along. Du, the derivative of 2x minus 1 is 2 over the square root of 1 minus u squared. And I'm going to put a 1 under there, so this will become 6 over the square root of 1 minus, I am going to go ahead and distribute this, because if it's a multiple choice problem, we'll want to make sure we know how to do that. If you distribute 2x minus 1 squared, if you FOIL that, you're going to get 4x squared minus 4x plus 1. And then this minus sign will distribute, so I'll get 6 over the square root of 1 minus 4x squared plus 4x minus 1. And then the 1's cancel, so I'm left with 6 over the square root of negative 4x squared plus 4x. And that's probably good enough to have it match with a multiple choice.